Muted.
Right. Well, welcome to the monthly GameSalad meetup. Your usual host, Alan Utoff, is out because his baby just got born.
Wow, that's awesome.
Let's see here. He just announced it. So.
Boy or girl?
Boy. Dylan Utoff, boy, 7 pounds. Mother and baby are doing great. Sometime around 4. So, congrats to him. And let's see here. So I am Tan Tran, your current host, and I'm also here in terms of the team with Steve Jakob, who has some exciting engine features to show off.
I don't know.
We have time?
Well, it depends if we have time or not.
If we have time.
I'll leave you time for that.
And today's speaker is, what is it? David Suzo, all better known to the community as GameSalad Guru, and his current username is Lost Oasis Games. Right? You have like a lot of. We need to start coming up with like a British Queen style name for you, just based off all your names.
Well, I played Clark Kent on the forums, but you know.
All right, so I'm going to close off the poll, and I'll share the results afterwards, and let us begin. I'll also turn off our webcam to reduce everyone's bandwidth eating.
Okay, so can you see my screen?
Yep, you can see your screen.
Okay, because I don't have a window to show me that you can see it. So, good evening, everybody. Morning, afternoon, wherever it is where you are. I know many GameSalad users are around the world. A lot of you know me. I'm pretty infamous on the GameSalad forums. The guru, as he said, Lost Oasis Games. They needed a volunteer for this month. Alan was looking for one, so I volunteered, and he told me he wanted to cover the physics engine, which wasn't really my strong suit, but I went ahead and dug in anyways, and I think I probably won't. I mean, man, it's tough to follow guys like Arthur, and you know, it's intimidating. Some of the great stuff he did last month. But I did dig through a lot of the information, and I managed to actually find a couple gems that I didn't know, and I asked a couple other really veteran guys. I'm like, did you know this? And they didn't know it either, so I didn't feel so bad. So I think it's going to help a few people. A couple of the little things that I found. I ran some tests. I just recently went onto the forum, and in the thread in the yellow sticky, if you want to go ahead and download the little packet that I put up there. I put in the PDF of the data of some of the tests that I ran in the physics engine, and some of the notes of the different things that I found, different pieces of information that I thought was pretty valuable, and help people kind of get a better understanding of how certain stuff is defined and used in the physics engine related to Box 2D, mostly to the attribute settings of an actor like density and friction, and things like that. I also did because I know it's a question that comes up a lot on the forums, I also went through and tested each one of them, but I did a little chart in there as well that covers what is editable at runtime and what isn't, to kind of, I know that's a question that gets tossed around a lot, and I don't think it's ever been kind of defined in writing. So I put that down as well, and I'll just show you. I did this little PDF here. I did some tests on the gravity. I wanted to talk to SOX because, you know, math is not my. I was an arts major, so. But I did run some tests on the gravity engine, and there may be a perfectly good explanation for it. But basically, what I did was I set an actor, and I put a couple of sample points up, and basically I left this, you know, scene set the way it was, and I just kept implementing the gravity, and I was basically monitoring the velocity at the different points and the time that it took to travel in those distances. And I just didn't, and maybe there's a great explanation for this, you know, the guys from GameSalad could say it, but I didn't see a consistency in the percentage. I basically kept adding 50 to the gravity, and I just found that the numbers just didn't seem consistent to me on a progression as far as a percentage in that. So it's just something that when you're using gravity or you want to work with gravity, you probably want to um, not just assume that when you've doubled the gravity that you're going to get double the velocity or we reduce the time in half. It doesn't seem to measure out that way. And it doesn't even seem to measure out in percentages consistently in steps. So those are all my numbers and my tests if anybody wants to kind of go through them and check that out. And these were the differentials here in speed between the numbers, and you can see that they're kind of all over the place a little bit. So um, if somebody wants to go through that and look at it, somebody that knows more than me about that, they can. But I'm just presenting that part of it as the facts. I mean, gravity's gravity, so um,
You may want to try plotting them out.
yeah, it's really not like this is not my wheelhouse. So, it's like did more of an observational, kind of a situation with it. It just, to me, anyways, it just didn't seem. I mean, it wasn't a lot, anything like radically departure in the numbers. But I would say that I wouldn't count on it being what you think it is. It just didn't seem like that, anyways. When I did those tests. So basically, we'll talk about a few of the behaviors and some of the consistency of setting up a physics environment, and then we'll go through some of the different things that I discovered in Box 2D, and I'll show you a couple of projects that I did where I kind of used the physics engine and built some stuff which I think were kind of unique in the way that I did them, and I'll show you that. There's just a little bit of different thinking when you're designing a game, one of them in particular. And I just want to get you to see if you to think a little differently when you're putting your stuff together. We can get pigeonholed sometimes in how we do stuff, and that was the case with this game with me that I was doing for a client. But anyways, I wanted to go through some of the let's go into the prototype. I wanted to go through just some of the attributes on the side here as well with density, friction, bounciness, and all this. So if you look at the list that I did, most of these are not editable at runtime. I tested each one of them, even though you have access to them. The ones that are editable at runtime are forgettable angular velocity, because that's just a representation of what you got. But you can edit these, max speed, you can edit the drag, and you can edit the angular drag. All the other ones their values have to be set at runtime. So I just wanted to go over, I set up this little scenario here just so we can see. I'm just going to test the drag out on this to see what kind of effect the drag has on an actor falling in gravity. I've got a gravity set of 600 on the Y, and what I found really was that you actually have to, it depends on what kind of or amount of drag you're looking at, but I found that I had to be, if I really wanted to see like some really marked results, some really, I don't want to say too drastic, but at least something that I thought was pretty noticeable, you had to get pretty aggressive with your numbers. So like, and I'm charting the velocity on this, so we can go ahead and just do the drop. And we'll see, we have a pretty high velocity here of 1081. That's hitting the first mark, and then that's hitting the time interval and the velocity at the last mark. So if I just went and say, I think a lot of people will go into the physics engine and say, oh, hey, I want to throw some, and 100 seems like a pretty high number, You'll go in and you'll say like, oh, let me put some drag on there. I'll put 100. But what we're going to see is that, I mean, it does have an effect, but you can see it's not really anything amazing. It's a pretty small depreciation off the velocity that we had at 1,000. Yeah, at 1,000. So I found that really I had to go up as high as on a 600, so almost half onto 300 on my drag, where you can really start to kind of see the actor. You can actually visually see it slowing down, and you're getting some pretty decent numbers on your decrease in velocity. So, I mean, it's obviously when we're doing stuff like this, unless you're building, and I don't know how many people have ever done it. I know most of us usually skip using gravity and all that kind of stuff in our games, because most people doing platforms. I don't know too many people that have done like a really kind of physics reliant game on kind of a reality on physics in GameSalad. I don't think I've seen one. Probably some people we kind of I don't think we've really delved into the physics engine on GameSalad, tested the waters really deep um, on it. But you can see that. So mostly, I think what we're looking for is kind of, this visualization. If we're putting drag on stuff, we want to kind of see things slow down and have some kind of an impact on the gameplay. So you have to, with drag, I can tell you just like from seeing it that you have to get pretty aggressive with your numbers. What you don't want to do is you don't want to match or exceed the number, because if you can't use drag as, let's say, like you would a constraint to try to stop velocity. And you can't use, excuse me, you can't use max velocity either. I tried that. Um, you get this same kind of real slow kind of drooping action here with it. And if you go over with your drag to what your gravity is, it starts just wigging out, just acting crazy. But so for drag, drag does, work in the physics engine, but you have to just be aggressive with your numbers. I think anything you're doing, with the physics engine, it really becomes, this balancing act of, it takes a lot of, you got to use all your different settings and the different tools that are in the physics engine and the proper behaviors to really get a handle, and you're creating this kind of equilibrium with the whole thing. It takes a lot of tweaking and adjusting and just knowing the right things to use basically. You can go in, and I think one of the things, I don't know, I don't think it gets talked a lot about the forums. I know I use it quite a bit, but I think a lot of people should really start considering, putting the max speed um, under the motions tab into play in your stuff, because especially with accelerate behaviors and accelerate towards, where you can't sometimes really control how a velocity of an actor will multiply off ricochets or bouncing and things like that. And so max velocity, which is totally editable at runtime, can help you control your actors and control the speed of your actors, and you can actually have, put your bounciness up and get a real aggressive, quick bounce from the start without having the thing jump off the screen by, picking a max velocity where you want that, where you want to cap that peak, and it gives you a nice snappiness with your stuff. And I found it to be, for a lot of stuff that I do, using accelerate and things like that, where I use max speed. And so it's nice that it's variable, because you can actually go ahead and, if you have key scenarios or situation in your game, you can go ahead and adjust that max velocity. So if you don't want it to be impeded, you just go ahead and put a high number in there. You can change that variable at runtime. So you can actually play with it up and down, and it really does help you kind of control a lot of these behaviors that can kind of go astray on you, and help you kind of keep a cap on things as a safety valve and get more control of the physics engine. That's one way to kind of balance, that's in there, the tool that's in there to help us, balance out what we're doing with the engine and with physics. This is the other one. This is one of the little gems that I discovered here that I didn't know, and I had asked a couple other people when I was digging through the Box 2D engine, and this relates to friction. So when I was reading the manual, in box 2D, it says that it calculates friction by doing an equation between the two actors. And if one of the actors is friction is set to 0, then there will be no friction applied to either actor when they come in contact with each other. So anytime you have one actor coming in contact with another actor whose friction is set to 0, the sum of the friction of both actors is going to be 0. So you won't have any friction. And see, I didn't know that, and I know that a lot of us who've been using GameSalad for a while have this habit of when we go in and we have a movable actor, let's say, we'll go in, and we're not using, if we're not using density for a specific reason, or friction or bounciness, we set all those to 0. And so, there's a lot of times I'm sure where people go in and say, oh, I want to try friction, and they try it and they weren't getting any good results with it. And that was because one of their other actors that they were probably interacting with was set to 0. And so, we can see that right here. I've got an actor here. It's not movable. Now, one of the things is that even when you make an actor not movable, all these physics attributes here, as far as friction, density, and bounciness, still apply. So I have this friction set to 0, and in this actor here, I have this set to 500. So we'll see now when I run this, you're going to see it drop, and it's just going to slide right down. But if I go in now and come to this actor, and let's say I apply a friction of 10, it's going to stop cold because now it's applying the friction. And so you have to make sure when you want to use friction between your obstacles and your actor or two actors, you have to make sure that they're both set to a positive value. If they're not both set to a positive value, then you won't get any friction at all. And that was something that I didn't know, and was probably the reason why friction wasn't never working for me. And so I think that'll help you because friction works really well, especially friction works well for one of the particular situations where you have actors not sticking on the platforms. That's probably the reason why people have, I've seen people in the forums and I say, hey, use friction, and they say, I've tried friction, it doesn't work. Well, it's probably the cause was one of those actors' friction value was at 0. And so, knowing how to properly use these things, now I'm sure people who will get this information will get passed around that will have better luck getting your actors to stick on another actor, knowing that how to properly set the friction on an actor. And then one of the other things that I did, and I put this in my in the notes how to do this, but I built a loop because one of the other things that we have in GameSalad where if you want to is with constrained actors. So if we're using constrained actors, I know we use the velocity in things like if we constrain to the mouse position to the velocity so that we keep collisions intact and all that kind of stuff. But I was doing some tests initially in Box 2D, and I don't know why. Maybe because usually when I'm using constrained actors, I don't ever want to look at the velocity. But at this point in time, I wanted to see the velocity of an actor that I had constrained. And you can't see the velocity of an actor that's constrained. It doesn't show up in the physics. If you go straight and do the velocity X or Y on an actor that you're constraining to something, there is no velocity. So what I did was I built this loop that will calculate the velocity of a constrained actor, and I measured it. It's accurate because what I did was I took this actor that I have the loop in that constrains the velocity, and I tied it to an actor with a move behavior set to go at a particular speed, and the readings I got were a match. So and the loop has to be as I've structured it because if you don't, your velocity won't be as it'll jump around really crazy. So I was surprised that I got the loop to be able to work frame by frame, layering it out, but it does. So hey, even a blind squirrel finds a nut, right? So you can see now you can constrain an actor, and you can track its velocity x and y, and this would allow you to do all kinds of you could build a snake off of this, you could do whatever, because now you can make other actors follow this one that you're dragging around and put offsets in it or whatever. You could even at this point where you have using magnitude against other actors to kind of stop it, as well having the velocity at the time it approaches. You can use your basic overlap and collide, and you could essentially calculate the force and simulate um, a collision. So you know that's something else that I came up with for everybody that I'm sure some guys will find ways to build out on that. Some of the real good math guys, like Arthur Thurman and Sox and those guys, I hope will build out and do some cool stuff with that. Um, what was the other thing that I looked at was, and let's just go through. So the max speed, like I said, is a good way to, oh, I know what I wanted to show. Oh, I'll show that in the, all right. So let me show you one other thing I wanted to talk about is I actually got an answer um, on this last week, and I ended up using it in that I made for my website. I had asked about, it's always been a question that I had that, and about stacked and additive in the move behaviors. And so I actually put it to use in this. I wanted to simulate a kind of a real water effect with the movement of this character I had. So we know if you've ever did any diving or whatever. I've been diving since I was 13. So when you're underwater, you have all these kind of currents that push up on you, and buoyancy is one of the things that when you're underwater, you're constantly messing with as air is leaving your tank, and you're wearing weight, and so your buoyancy is constantly changing. You have a BC, a buoyancy control that you fill and release air in, and so you're always trying to mess, and you've got these different currents, the tides are moving and all that coming in. So I wanted to kind of simulate that that effect where if it would feel like it would get a sense in the controls that you were getting these currents kind of pushing you in these different directions, but I didn't want it to be I wanted it to be kind of random and feel more like a buoyant experience. So what I did was I have my controls here, my basic controls that I did, and I used in these I basically have up, down, right, and left. But what I did is I used the additive function in these move to behaviors. So basically, as you see, there's a little pop-up that I never even spent the time to look at. And it adds the velocity to the current velocity. So what this allows me to do is using additive on these is that if I'm hitting the down and the right key, it's going to put me on that angle instead of just forcing me in one direction. Or if they have basically the same speed, so what it's going to do is pull those speeds together and then put me on a trajectory that'll be more in between those two movements. So it gives me an angular movement without me having to have like a joystick type situation. I can just push two keys down, and it's going to give me a left-right because all these speeds become and the directions become additive in my actor. So then I set them on a basic straight up. So then what I did was I came down and I did a stacked buoyancy control on top of that. So what happens is that this part here, I put them on a random speed, and I put them on a random direction in a short window, basically based on up and down with my character. And so basically this loop just keeps cycling, basically, well, it's a loop kind of, and it just keeps switching between these two basically every 5 seconds. And it keeps picking random speeds and random directions. So what I found is happens in my game is if at some point in time it's scanning so many, it's looping so many times that eventually when I'm moving up, I'm going to hit that direction where my random direction is going to be in proximity of the direction that I'm currently at, and it actually puts that value in there, and it gives a bump, or the additive one adds to this one, and so you'll be kind of swimming along, and then I'll show you. You can almost see it a lot of times. That you'll get these. You can see that's the behavior right there, moving it kind of, because I wanted to simulate kind of floating in water. So it gives you that kind of sense of floating in water where he'll just kind of bounce up and down with that loop that I made. But then when you're kind of going in a direction, you'll see it'll be steady, and sometimes it'll just like pick up speed. If I can get it to do it. It was doing it for me earlier. Yep, see it pick up speed there? And so it gives you these little anomalies that you would, that gives it more of a natural feel where I'm not taking away, like, I'm not making you lose complete control of the character, like, every 5 seconds or every so often. It's more like every so often, so you'll get this current that'll come up and, give you this little, oh, I'm not, always in complete control of the character, like the water would be under there where you're trying to swim in a direction and the water's pushing on you. So I was able to really accomplish those things using the stacked and additive situation there with what I asked a question last week and learned. And so this is the other thing I wanted to show you with the physics engine. Now this is a game that I built for a client, and originally when I had started out, I was basically in a conventional mindset. So I have these balls. They're all different kinds, and there's 4 buckets that show up out on these benches, and there are different types of balls that come down, and it's like occupied, and you have to sort the proper ball, toss it into the proper bin. And I used gravity because it was really a lot easier in this kind of a game to use gravity, because I didn't want to have to mess with changing around, velocity and all that stuff in different directions and all that. So it was just easier to have the gravity and let the physics engine do most of the work, and then basically all I had to do was work on what I was going to allow the velocity to be when you grabbed the actor and then tossed it in a particular direction, and where it would kind of find its arc, lose its velocity, and then the physics engine would take over from there with the gravity in the world that I created, and take care of that stuff. So originally when I started building the game, it's typically, thinking about, okay, I've got to spawn these balls, and I've got to time it. So originally I basically had a spawner at the top here, and I was trying to spawn the balls down the locker. This door opens when the game starts, and the balls come through. And so now I'm trying to, this is the thing where because I did all this research about response times and touchings and all that stuff, and building out the 3 levels. And so you're looking for a certain speed, since I was using gravity, where you want to have a certain velocity where the ball is going to drop, take how much time it would take from the bottom of the locker till it got out of range where you couldn't grab it anymore. And so you've got to kind of fix that number with your gravity, but then that leaves you stuck with being able to want to release the balls at certain intervals, and as well as to be able to not have too many balls coming out at once, and trying to handle all that kind of stuff. I found that because I was kind of stuck with the gravity, using the gravity on the balls, that if I adjust, it didn't matter whether I adjusted how it was spawning or whatever. I just couldn't get things to be really tight because the timing on this stuff really came down to hundredths of a second on some of these things, especially on the higher levels when things move faster. So um, I was really frustrated. I was like, I don't even know if I can do this. And then, so I thought about it, and I come from an electromechanical background. So I thought, I'm using real physics. I'm like, why don't I just do this mechanically? Let the real physics kind of work, and then I'll build a mechanical sorting system with gates in it. And so I built this area that you see up in the top here, and I'll show you how you can see how it starts. Oh, let me turn this down. And so the locker opens, and you start with some balls, and then they can start releasing the balls and capturing them at the particular intervals. But what I did up here was I built like a mechanical sorting system, so I allowed the balls to just spawn, and then I didn't have to worry anymore about trying to match the spawning with the gravity coming down. And so I just let the ball spawn and mix up in here, and this little actor up in the corner is basically like a level indicator. It'll tell the spawning system, all right, I've got enough balls in there for right now. Stop spawning until the locker is getting more, and you'll see once it gets past this, it starts spawning again. But really, what that allowed me to do was, kind of taking an unconventional approach and building this whole system kind of up inside where you don't even see it going on in the game, allowed me to just focus on at what intervals I was going to release the balls, because I have these gates, and as you'll see, these, the balls are all different sizes. So it was really tricky to try to get with the gravity, and then of course as it has an easy, medium, and hard, so as each level goes up, the gravity increases, so that means the quicker these balls fall in between the gates. So I had to have 3 different adjustment times as well for these gates, depending on the amount of gravity I had on a scene. So dealing with the physics engine, sometimes when you're setting gravity or you have gravity, then it's gonna depending on what you're doing. But once you have a gravity world, now you're kind of boxed in by it, and sometimes you have to find other ways of you're going to use that gravity, but find other ways that maybe are unconventional or different, but in ways that you can, say, okay, I've got gravity, now how can I take advantage of the fact that I have gravity and do what I want to be able to do utilizing it, utilizing that force in my game. And so this was just, I thought, one interesting way that I had used gravity that I thought was kind of outside the convention, in that I built a whole system that is hidden. You never even see what goes on. It's just that system's there, just built to harness all these balls, mix them up, and then channel them down into the locker to be fed out through this gate system I did on here. So certainly using gravity all the time, gravity can be a pain, just because of the way that we have to, everything becomes movable now, and if you want to, like in a platformer, if you want to move a platformer, if you want to do have obstacles that spin or whatever, and then you're stuck interpolating, and then when you interpolate, you don't have all the collision stuff that you want to have, and all those kinds of things. So, and there are a host of different ways that are techniques that are out there for using actors in a movable situation, and yet still constraining their position. Basically you can come into an actor and you can basically just constrain its velocity. So you could come in and change its velocity. Just come in and grab the velocity under motion, angular velocity, and you can constrain the x and y's to 0. You always usually want to grab the angular velocity as well. You can constrain that to 0. You can fix the position. We can fix the position of an actor to, let's say, if we've got a platform moving side to side, we can fix its Y position to a set height, and then we're only worrying about moving the X and Y back and forth. One of the other things that that can help you with doing a platformer as well is if you have an actor and you want him to get on the platform, what you can do is, in all your obstacles, you don't have to, since your actor is only going to be on one obstacle at a time, let's say a platform, and I wanted to basically, so if this platform here is moving on the X, the best way to keep my actor on the platform is when he's not moving in my control system is to say when he's overlapping, colliding with this actor here, what I want to do is you can just make one. You can go in and make a velocity X and a velocity Y, okay? And then you don't have to have 100 of those things for every platformer you have. You can just make that start sending that particular platform, start sending data when it overlaps and collides with your hero. And then this way it slims down your code, so now you can tell your hero, if you're overlapping, colliding with, any one of your platforms, and you can just use a tag function to identify it, then you can tell your actor to constrain to whichever way it's going. So you could tag all your obstacles or platforms or whatever that move with an X velocity with one tag, and then the ones with the Y, you tag them with another tag. And then you can go in and just basically say, okay, when you're overlapping, colliding with an actor that is moving on the X position with whatever tag, you can tell it to constrain itself when it's not moving to the velocity of that actor, and that'll keep it in sync with when you're not moving around on the platform with the platform without having to worry about friction and all that. And you don't need a million variables to do it. All you need to do is when that actor is touching the other one, you just have it start reporting its velocity, and that's a good way to keep in the physics engine, to keep your platformer on an obstacle of any kind. And then friction is good for if you've got an obstacle that might happen to be spinning. A lot of times in platforms, guys have an actor where it's spinning, so you put some friction on there. Make sure both actors have friction on them, and that'll help your characters from sliding. Give the player a fighting chance on that obstacle without sliding off too quickly. Those are just a couple of methods. A few of the methods that I use. I've used this particular method of keeping an actor on a platform quite a bit. It works really well as long as you set up your code right, and by doing it that way, you keep it really slim. So there's a good chance that you'll quickly be able to debug any issues, and you're not having 100 attributes that you're trying to keep track of to keep your actor constrained to a platform or an obstacle. So I don't know. You want to open it up for questions? If anybody wants to ask me a question, or
don't see any questions on the question system yet.
Okay. Well, that's about all I got. So.
Oh, well, okay. You're opening up for questions because you were done. All right. Cool. Thank you very much. That was pretty cool.
You're welcome. Thank you.
I always like playing this mechanical system. We had problems with the physics engine when we first were starting with GameSalad, and then we were trying to build Pong. But if you set something as immovable, in order to get because of, what is it, Newton's, I forget which law is which, the reaction equal reaction law?
Right, opposite reaction, right.
If the ball hit the paddle, of course the paddle would move down slightly too.
Right.
So what we ended up having to do, and so we couldn't build a paddle in breakout, I think this was for breakout, that wouldn't move. So we ended up creating two immovable, invisible rails for it.
Right.
And so that would keep it in between the rails, and so you could only move it. It would only move in one direction, which is
Yeah, you still have that issue with platforms. Even if your actor on the top the density is set to 0, you'll still get some movement if you have a movable platform and you don't constrain the Y. It's very little, but it will progressively move, if you keep jumping on it, which I
All right.
thought I was hoping that density would, you know, but it just doesn't seem like, you're going to get some force on there. It just seems like, no
All
matter how
right.
high you set the density.
So I'm going to share the last poll results while we see if, are you in a position, Steve, to...
Sure, yeah, I can do fine.
Okay. I'm guessing you're the other organizer.
And those files that he was doing, they're going to be kind of available. He mentioned putting them on the forum or something.
Oh, yeah.
Yeah, they're in the yellow sticky right now.
Okay, cool. Yeah, I'm looking for just any new sample files for, working in the 1.0. I don't have anything. It's hard to find stuff. So this will help me.
Yeah, if you go to our learn.gamesalad.com, there's a lot of stuff there that you can look at. Let's see here. So, did you get the request?
Not saying anything.
Oh, okay. I don't know who's getting the show.
Quick poll, we can't get rid of.
All right, I just made the main bullboy the presenter. Maybe. Oh, no wonder. I gave it to. I thought you logged in as one of us.
Yeah, I guess I'm logged in as Steve J.
Presenter. Right. So, ready to go when you are.
Sure, go ahead.
Yeah. Oh no, then you're set. You should be.
Oh, do I need to do that?
Yeah.
It says muted.
Yeah, currently I need to share my screen though. Let's see. Screen sharing.
Wow. This is a very low question day.
Well, they might all be like me. I'm just looking for any cool ideas.
Okay, cool.
All right.
Okay.
You're up.
Can you hear me?
Yes.
Okay. It says I'm muted here, but I wasn't sure.
You're on the phone.
Okay. Okay. So as you may have seen in the forums, I'm getting some feedback. That's all right. As you've seen in the forums, we've got a couple new features coming in the next release of GameSalad that affects physics, coincidentally enough. So that's a nice synergy there. One is custom collision shapes, and the other is being able to set a center of mass, which affects your center of rotation of objects. So I'm going to just show you a quick little demo of how those work.
Nice.
So I got this paint program here where I just created this sort of semicircular shape with a black background and a clear center here, and I'm going to create a collision shape based on this. So what I've done is I've already saved this thing off as a PNG. And for this demo, I'm just going to use this third-party program called Physics Editor. Let's actually get a new project here. One thing with the custom collision is, unless you actually want to hand enter in the coordinates of the vertices of your custom collision shape, you're going to need to use a third-party program. Possibly, hopefully, knock wood, sometime in the future, will allow you to edit collision shapes within GameSalad Creator itself. But currently, you need to use a third-party tool. We're supporting two different tools at the moment. We may support more in the future. This one is called Physics Editor. It is a pay-to-use program. It costs about $20, but it's pretty clean and easy to use. There's another one that's based on Java called Physics Body Editor. These guys have really original names for their products, which is free, so it has that advantage, but it's written in Java and it's a little awkward to use. There's instructions on the GameSalad website in the cookbook section about how to use that. So for right now, we're just going to go ahead and use Physics Editor to create our body. So what we do here is we start off with a new system here, and let me just minimize that. One thing we want to do, first thing we want to do here before doing anything else, is we want to change the exporter to GameSalad. And this is a custom exporter that I wrote. It's available again on our website if you go to the custom collision help page. And it'll tell you how to install it. We're actually looking to see if we might be able to form a partnership with these guys so that GameSalad actually comes bundled with this. But we haven't heard back from them quite yet. So once you set up the exporter, install this program, download the exporter from us, set it up correctly according to the instructions on our website. You set the exporter to GameSalad so it'll output the right format. And then you just add your image to this program by clicking Add Sprites. And we'll just go ahead and add that guy there. And let's zoom him up a little bit so we can see him here. Now you can manually, with this thing, you can actually manually add points to define your shape, but it's much, much easier just to go up to here to this little thing and just click the tracer here and just hit OK. And that'll add the points. The next thing you want to do, once you got this running, and this is the same for the other program and pretty much any program that's going to do auto tracing for you, is they're probably going to make some errors when where you're looking at your shape. So for instance, here I've got these two dots next to each other, and we don't need both these dots because the less amount of vertices you have for your shape, the more efficient your program's going to run. You want as many, enough vertices for your shape that it's going to, conform to your shape nicely and collide with it. But you don't want to overdo it. You want like a dot next to a dot next to a dot next to a dot, because that's just going to increase the amount of computations that are going to go on to decide whether something collided with your shape, and it's going to slow your game down. So you want basically the bare minimum number of vertices to define your shape. So I'm just going to go ahead and delete this guy. So we don't need that thing. But everything else looks pretty decent for this particular shape. So I'm just going to go ahead and save this off by hitting this publish button here. So click that, and we just go ahead and just save this off as top2.json, and just replace the old ones there. So that's all we need to do with this program. So we can go ahead and close this guy out. And I'm not going to bother to save this project, but it allows you to save the project if you want to modify it later. But I don't need to do that. There we go. And so now I've got GameSalad here. I'll start up a new project, and I'm going to go ahead and add an actor here, and open this guy up, and let's go ahead and drag my image in. So now I've got my image, and then I'm going to add the magic and change this collision shape to custom. It pulls down this drop down here. It tells you this is a new feature and you need a third-party tool to add shapes. If you go to this Tell Me More button, it'll actually open up the web page that is the collision help. So it'll give you all the information. If you've never seen this before and you just happen to click collision shape custom, and you've never heard of this, you can click on this Tell Me More, and it'll take you to the help page, and it explains all the details about how custom collision works and how to get the third-party programs to set up collision shapes and whatnot. But we already know how to do that, so I'm just going to go ahead and grab my custom collision data. So the data is here in this top2.json file, and we'll just go ahead and import that successfully. Then we're going to want to give our object some physics properties. So let's go ahead and open this up. So 100, and like that, 30, and let's make this not bouncy at all. One thing I want to do is make sure this. I'm going to add. What I'm going to do is have an object to bounce along this and roll along the shape here. So I don't want this guy movable. So he's just going to be a fixed thing. So let's see. Let's go ahead and add And let's just go ahead and give them this ball shape. And let's give him some physics properties. And we won't want him to bounce either. And we'll give him a collision shape of just a plain old circle. And of course we don't want to move fixed rotation. And of course we want him movable because I'm going to drop this wheel into that semicircular shape, and you're going to see it roll along there. So let's go ahead and go to our scene. Let's go ahead and make the scene background white, because our little semicircle there is black. So we can see it. So we'll drag this guy on here, and let's go ahead and rotate him. Good enough. And let's stretch him out. Maybe drop it down a little bit. Good enough. And let's drop this guy and maybe shrink him down a little more. Let's give some gravity to the situation. That'll help. So there we go, and it's going to fall right through because I haven't set up any actual collision yet. So let's go ahead and say actor 2, you collide with actor 1. And now,
very nice.
It rolls along.
Now you can turn into a little skateboarder.
Yeah, you get to make a little skateboarding thing.
This will be real helpful.
They do steps and all sorts of things.
Yeah.
I think today's presentations are blowing everyone away. No questions.
Yeah. And since I set the friction low, this guy will keep rolling along for a while there, but eventually friction will catch up and it'll settle down there. So that's custom collision, and basically, yeah, you can make your collision shape however you want it. You can have holes in your objects. So you can, for instance, have a donut where you have something that's like moving around inside a contained area. One of the incentives to actually implement this was one of the heads of the company wanted a pinball game, which we couldn't do. But now, yeah, we should be able to do pinball games with it. So look forward to seeing somebody do that. So let's talk about the other thing that we're adding to the GameSalad. Let's go ahead and get rid of that. Start off with a new project. This is being able to change the center of rotation of an object. Let's add a couple actors here. Let's just go ahead and change the color to red. I'm just going to use this red object as a reference point. I'm going to place this guy with his upper right corner about in the center of that red guy. And what I'm going to do here, go into this guy, and I'm going to say, give him a rotation. There you go. And you'll just rotate. And so we go here, and he rotates around the center. You know, no big deal. You've seen this before. But if we go in here, we're going to motion, center of mass, and I know his size is 100 by 100. So I'll set his center of mass to 50, which is his upper right corner, because the center is the center of the actor, and then it goes positive to the right and up. So we go there. Now he's rotating around the corner. And the reason this works is because Box 2D rotates objects around their center of mass. So you set the center of mass, and it will rotate around that point. However, one thing to remember is that box2D considers all the mass of this object at that corner. So when it's moving it around, if you like you add gravity or whatever, the gravity is going to be affecting effectively that corner rather than the center of your object. There's no way to separate the two as far as box2D goes. It always is, you know, you can't say don't rotate around the center of mass, or you know, rotate around this point, but consider the center of mass at some other point. Box2D, the center of rotation is the center of mass for all objects. So that is you know, hopefully that won't be a problem for people, but it is. They'll have to find some other way to work around it. But this is a kind of a nice little convenience thing. If you want an object that we want to rotate, but you don't want it to rotate around the center, you can use this little feature to give you a little extra, you know, something extra to play with.
That's great.
Yeah.
I just realized you can make like a balancing game with this, where you make a stick with some like a heavy top, and then you can just like balance along the bottom. Or
potentially, yeah. Yeah. So these features are currently in QA, and once QA gives it the okay, we'll be releasing it. I was hoping to get it out this week, but we've had delays for other reasons. So probably sometime next week it should be out. Any questions?
So far, no. All I've got is custom collision feature is awesome.
Oh, thank you.
And very helpful presentation guru. So let's see here. Since there aren't a lot of people, prepare to mute yourselves if you don't want to be unmuted. I'm going to start unmuting everyone and seeing if everything works okay.
These features are working across the board on the PC and Mac version?
Everything, yeah.
Okay.
Yeah.
So they'll come out simultaneously again?
Yep.
That's going to make life a lot easier.
Also, yeah.
Yeah. Never mind.
Rotating an actor was on and offset was such a pain.
Yeah, this will definitely make things easier. You won't have to like make your actor bigger and then have a lot of clear space, like I saw one person suggest on the forums, or you know, do complicated
Yeah,
calculations.
that works good for collisions. If you want collisions, then you'd have to do the math, you know.
Oh yeah.
Like we're doing. But like when Steve was showing that rotation, I mean, an easy thing to do to just change the center mass would be just to attach another actor to that.
Yeah, see, that's what I did.
Yeah.
I had to do the trigonometry and put a bunch of actors together. It wasn't easy.
Yeah, it's not. You know, this like you change it and
Yeah.
actually
Yeah, that's definitely
a little
helps.
more intuitive setup.
Yeah, I was doing a little spacecraft flying game, so it kind of needed that.
Mm-hmm.
Yeah, no, those are both huge. Both of those, I think, are huge advancements for the engine.
Yeah. Yeah, and oddly enough, they were actually fairly easy to implement. The custom collision was already about 80–90% done. Evidently, it had been implemented, or at least partially implemented, for a game that we had done at some point in the past, but there was just no way to get the data from the actual GameSalad creator into there. So I'm not sure how they did it originally. I guess somebody just hand-entered numbers.
Yeah.
Luckily,
we only need it for one actor.
Yeah, which sounds horrible. So basically, all I need to do was just come up with a file format to get the data in there, and fix a couple of bugs that had cropped up. And then the center math thing took about an hour to implement. So yeah, it was all pretty simple to do.
Is it still possible for a user to hand enter numbers?
Yeah, I mean, if you want to go into the XML data for your actor and enter numbers, you can.
You could also
I wouldn't necessarily recommend it, but yeah, you can.
Yeah, if you don't want to break down the file, you could also just hand enter them in the JSON, like just.
Yeah, you can look at you can basically create and the help page for custom collision actually gives you the JSON format, file format that you can use to create your data. So if you don't want to use these programs, or you want to write your own program to generate the vertices and whatnot, we give you the file format to use for importing.
Here, I'll see here.
If you think very simply ahead of time and you plan, your image sizes and stuff, it is possible you could just throw some numbers and know it will work.
Yeah, if you don't have like real complex shapes or anything, yeah.
I'm just going to show the documentation while that. All right, poll results real quick. So, wow, a lot of people making big games. Nice. 50 megs is a big game now?
That's kind of a lot for mobile, right?
Yeah, for mobile, yeah. I mean, it's like that's the. I mean, it's like what? Android is 20 meg.
No, that's 50. I think 50 megs is about.
Okay.
Yep. Yeah, I was like, hold on.
Yeah, they boosted it. They boosted it up now to 100. You don't have to do that separate package anymore.
Oh yeah. So there's the help page for custom collision.
Cool.
Nice.
And it says GSMat cookbook on the right-hand side there, but you can get it from the Windows side as well. They both link to the same page.
Yeah, you just search for custom collision, or even, I think it's the only thing with the word custom in there. If you search for the word custom, those articles will come up. Those are nifty little strips there.
Yeah, so there's the information about the JSON format.
So does this, if you put, right, I think we're assuming right now you can only put one rigid body in there and it's just a...
Right, there's only one rigid body, but it can be made of multiple polygons.
Oh, you can multiple polygons.
Right. And a polygon can have up to 8 vertices.
So what the file is doing is if it has a lot of vertices, it's automatically breaking the polygons for you.
Yeah, the polygon, the limits of the shapes are, you can have as many polygons per object as you want. Each polygon has 3 to 8 vertices, and the angles between the sides of the vertices have to be convex. You can't have a concave shape. So if you have a concave shape, you need to break it down into non-concave segments. Yeah, and there's descriptions about how to use both the two different editors that we're currently supporting there. So there's the physics editor. There's the link for the plugin. You scroll up, you'll see the information about the Java one.
So, did the plugin basically just output the same format as the Java one?
Yeah, yeah. Yeah, actually, it does have a little extra data because it treats this slightly differently. So, but it's effectively the same.
All right. Looks like there aren't any more questions. So, here. Last usual near end of session polls, unless anyone wait if anyone has any questions. Oh, this might be a question more for the GS peeps. So Joshua Reeves is asking, I don't quite understand Guru's first test. What was the reason for the apparent unrelated values? Unsimple test, just bad results. I'm curious about plotting the values instead. So I was actually playing with this. Let me see if that project is still up. It's not. I didn't allow the project. I made a project, and basically, I could see that there was acceleration going on if you were, it seemed to be accelerating properly. What I did is I set up a similar test, but with a lot more checkpoints. So I think I set it up where there were 10 bars along the screen, and then put an object at the top, and every time I hit a bar, it would record the speed. And because I was a little slow, I was thinking, it's accelerating. I should see the speed constantly getting getting faster, but what I forgot was I placed the bars evenly. So what happens is because the speed is getting faster, the difference in speed you see in the evenly spaced bars gets smaller and smaller because it's hitting the next bar faster.
Okay, remember gravity is acceleration, not velocity. So I'm not sure. I've been trying to look up the units for that, and actually, even I'm confused about the units that gravity is in.
Yeah, because I measured bar against bar. I didn't measure. You know what I'm saying?
Yeah.
So if you look at my chart, every step of 50, I measured the red bar against the previous red bar.
Yeah.
You know what I'm saying?
Yeah, and so like if you wanted to see a difference in speed, you'd have to figure out how to measure based on time and not. So if you measured every few seconds, then you'd start seeing the speed increase faster and faster.
Right.
Yeah,
Velocity change faster.
Yeah, I plotted the time too on each one. I mean, if you guys want to look at it, I have the charts in there. I went from, I think I started at like 100 and went from there and all the way to like 1,000.
So I'm going to
And
make
charted all the time intervals for each bar and the velocity.
So I shared it shared with you again if you wanted to show your charts. If not, then that's fine.
No, they're there for anybody that wants to see them.
Okay. So I guess I'll share poll results real quick.
But I mean, the idea was that I was just saying that, if you're looking to double your velocity, don't count on, if you're at 100 and you say I want to be at a greater speed, that if you go to 200, that's what you're going to get.
Yeah.
Yeah, no, that would.
Yeah, I want to do some research and try to find out the exact units that all these physics items are.
Yeah, well, I know that Alan told me that in Box 2D they've got it set up so that every 50 pixels is 1 meter.
Yeah, that's in our system, in the way the GameSalad works, interfaces with Box 2D, that is correct. So for distance, that's true, but I'm not sure about
Right.
force.
I assume the forces are in pixels per. I'm not sure. I don't know for sure, but that's what I got to do.
Yeah.
Yeah, I knew there had to be some explanation, but I know, like most of us, I imagine that's what we'd assume, which is why I was pointing it out.
Yeah.
At least that's what I assumed. So.
Yeah, it took me a while to do the math backwards. I haven't done that. How to double? How much you have to change acceleration to double your end speed?
Right, that's the point. Right.
Yeah.
It's kind of like sugar, and you have to put 3 times as much sugar. It tastes for 2 times as much. It's really weird.
Exponential.
Yeah.
Yeah, it seems like that way too, like with friction and stuff. And I think that's why I was wanting to bring those things up, because I think people just, I think you just kind of naturally make those assumptions, and so I wanted to get people thinking about those things. Where your friction to really get something to really show a decent result, you really had to jack it up.
Yeah.
And I think a lot of people, I've seen it a lot in the forums over the years, where just people say, we'll say throw friction on that, and somebody will say, well, I tried, and so I just don't think people are being aggressive enough, obviously.
Mm-hmm.
And I just think because it just seems odd. It's like, oh, I'm gonna half the amount of friction based on what my speed is. It just seems like it's too much, but it really isn't.
Ted C has commented that you make it hard to do my usual nagging when you're giving new features like this. All right, let's see here. So it seems at some point, if anyone knows anything, wants to talk about marketing their games, that would be awesome, because apparently a lot of people want to know how to sell their games better.
That's a really good question. Yeah.
Oh, yeah,
That's the $1 million question. What do you mean?
Yeah.
So I just put this up here for fun. This is a preview of our new homepage, or what's going to be the new default homepage when you're logged into GameSalad. We're like doing a revamp of some of the basic parts of the page, and so this is kind of what that's going to look like.
Nice.
And so it will, depending on whether you have Well, the order of the items will be slightly different depending on whether you've actually published something or not. If you haven't published yet, learn and play are at the top. So you're actually.
Oh, that's cool.
That makes sense. But
Yeah, just so people know too, I'm doing a video series on the physics stuff, and I'm going into more detail. It's probably going to be a few parts, and I'll be putting it on the Academy.
Cool.
Getting a little deeper into picking behaviors and things like that, showing all the different ways that all the different methodologies that you use, like I explained, kind of with getting something to stick on a platform or stopping something's velocity. And I get a little deeper into actually how to code it out,
So it seems like we're ready to wrap up here. I haven't seen any more questions, and if you raise your hand in the session if you want me to try to unmute you. Otherwise, I think we're done. And the poll with 71% of votes say we're done. Okay. So I'm curious what the other 40% who said no want. If they want more, they need to start putting in some questions.
They want joints.
Yeah, that's gonna be trickier.
Yes.
Yeah.
Never satisfied. Yeah.
Nope.
We want joints too, but yeah, it's gotta be
I
tricky.
always love it. I love it. You guys will always put out like 2 or a couple new features, and then here it comes. When is this coming?
All right, I'm going to end the recording now, and